Welcome to the Plant Kit deep dive workshop. We'll be running this over today and tomorrow. And, you know, obviously, as I mentioned before, you can check the website and the blog posts and the news to see any other additional workshops coming down the pipeline. We do plan on having a few more coming up potentially. But for today, we just kind of want to give an overview of, why did we develop? Why did, Chris mainly develop and, really get LandKit and more specifically PlanKit running and developed for people to use. And it really, comes out of this idea of like design today still kind of runs in this whole drawing on paper and then translating it into the computer. And so the computer tools really end up just being sort of like the end of the design process, tools that you use that will eventually become construction drawings and so on and so forth. But the real frustrating part about it is, iterative design is very difficult in the way that we do design today. Despite having all of this computational power, we don't tend to use it as much as we should or maybe can. And so what it ends up being is a situation where you can only do so many iterations and redo your whole design and translate it back into the computer so many times before you run out of time or money on the project to be able to explore new options or try new things. And so LandKit sort of was born out of this idea that we have all of this computational power. How do we harness it in a way that allows us to utilize the full power of a computer and be able to sort of, maybe start still with that analog drawing of developing ideas, but maybe even translating that into the computer from the beginning, and then providing yourself the tool sets to be able to really iterate through quickly so that you don't run into that issue of running out of time and money. You can really explore the options and provide the best solution and best designs to the clients that you're working with. So honing in on planting design more specifically, there's a lot to planting design, as you all as professionals know probably all too well. There's a lot of expertise that's involved. There's a lot of, plant lists and analysis that goes into it. And there's so much stuff that you have to keep track of just kind of in your head or as much as you can on paper in order to make sure that you're placing the plants in the right location. And it's just, simply too much for the human brain to deal with, taking into consideration all the environmental analysis layers, the design decisions that we're making. And some of the best planting designers and horticulturists can do a pretty amazing job at handling this type of analysis sort of in their head. But I would guess that even the best planting designers and horticulturists would probably say they still miss quite a few things. But you end up with all of this time and effort that goes into the planting design, and you create a visualization of it or a plant schedule or a planting design plan. And if you have to change something, you kind of have to reset a lot of that process and redo it again. It's very time consuming and difficult. So, we use this diagram for a lot of our LandKit workflows because that's really how LandKit was developed, and PlanKit specifically is how do we create sort of a circular process where we're feeding in the parameters that are related to our site. So the environmental parameters or the analysis that we're doing, the different rules that we're trying to follow in order for our planting design to be being planted in a specific way. So if we want flower colors to be in one certain area, maybe we only want red flowering colored plants in one specific area, those kind of layer in on top of these different analysis layers like moisture level in the soil. And so you can feed all of that information in and then continually have that information updating live as you're working. And then as you update it, your plants will replace on the site and provide outputs for documentation, for 3D visualization or two-dimensional visualization, for plans. And so the whole time you're inputting all this information right at the beginning, and then you're seeing the results of all this analysis and all these design rules that you're inputting. And then if you don't like it or you need to change something or you have a new iteration, you just adjust those inputs and it reprocesses everything instantly for you, so that you have a real feedback loop on inputting information, seeing what's happening, adjusting that information, automatically seeing what's happening as you're going through the entire process. And so it makes it a little bit more fluid, and the front end design is a little bit more setup is a little bit more time consuming, but overall you will save more time. And that's sort of the design approach. Go ahead, Chris.
In a way, I like to think it becomes more like drawing in a way, and not redrawing. It's that kind of hand-mind connection where you can actually change something and see the results and sort of respond, and it's not kind of like going through this huge long process before you realize this doesn't look right,
and then hitting reset right after that.
Yeah.
So we're going to go through a couple different diagrams that kind of start to lay out what's happening in the scripts and in the Grasshopper and everything that and the workflows that we have set up and available. But in general, you're kind of working with these two main inputs that are coming in. You have your environment that you're building, and you're adding these different layers of analysis to, and all of those layers of analysis are being packaged into a single Grasshopper like data instance called the environment. And inside of that is three-dimensional data. It's just data that's being used to decide where plants are being placed. It's like a rich piece of instance that's in Grasshopper that you'll see you can add stuff to and make it more complicated and more rich. But then sort of the other element that's coming in, and in addition to the environment, you'll plug in planting areas that will become sort of your zones of focus where the plants will be placed. And then the other major thing that you're dealing with is the plant lists. And so how do you bring in all of that information? Each plant has a range of different traits that you're dealing with. How do you bring in all of that information related to the specific plant in order to have that plant placed in a location on the environment that relates to the traits that it prefers? So the plant list is something that you'll see is super exciting, sort of based off of some databases that we worked with, where you have all of these different traits and you can just create your own CSV and apply all these traits through and bring in a single CSV with all of your plants and filter those through, and then eventually have only the plants that work on the site in the specific environmental conditions being placed for you. And then this is sort of a conceptual framework of how it's going to look once we get into Grasshopper. You're using at first sort of your topography and your environmental boundary, the boundary where you want to be doing your analysis. And that is the beginning of your environment, and you can add more layers of analysis into your environment, which then feeds into your areas. And then these areas are the planting zones, basically a square, rectangle, any shape that you want. And so inside of those zones is where the plants are being placed based on the environmental conditions. And then those come together in the layout plants, combining in your plant data to actually place your plants on the site to create blocks or visualization nodes, or other tools like bloom calendars and plant schedules and things like that. But there's this other little piece down here, the add niche, that we'll get a little bit more into once we're in the demo. But niches are really being used in PlantKit as a way of adding traits to a plant that will influence where it's being placed, that are not embedded into the plant itself native to PlantKit. So inside of PlantKit, you have a few different traits that are just embedded within the plant, such as the plant height, its radius, sort of how much space it takes up. But then the niches allow you to add in things like its sunshade preference, its soil moisture preferences, really any type of trait that you could imagine in your head, you can add in here through your CSV and have your PlantKit workflow processing and using that. Go ahead, Chris.
Yeah. So basically you bring a plant in and it has the data from the CSV sheet, and it's not all necessarily creating attributes of your plant yet. You more explicitly say, okay, I actually want to take the sunshade information and apply that as a constraint within my niche. So the niche is sort of composed of these different constraints. I know Ben's been using the word trait, and that was the main reason I hopped on, was just because
it's good.
I like to think of them as like constraints in the niche case, because it's about, okay, it's constrained to these kind of environmental conditions, really.
Yeah, so, and again, speaking directly to what Chris was talking about with the constraints, these different traits are thought of as constraints, and in order to place a plant on a specific location on your site, you're analyzing the different constraints that you've applied to the plant and overlapping them to find the location where that plant can be placed. And it's plausible that multiple plants could be placed on the exact same spot. And there are actually ways inside of PlantKit that you can sort of give preference to certain plants over others that you'll see, and we'll show you a little bit of using weighted values. But sort of the database that the way the CSV sort of processes through PlantKit is built around our usage of the ecoregional revegetation application, the ERA, by the Federal Highway Administration. So you can download massive. I mean, it's I think one of the largest plant databases available for free online right now for the US specifically. And it has all of these different traits and columns. There's so many different constraints and for each different type of plant. And you can download different sections of them. But a lot of the terminology that's used in the ERA database is sort of where a lot of the terminology is used in the plant kit. So if you're making a CSV and setting it up and you're confused as to why something's not working, sometimes you can go back and reference this to very quickly figure out what's going on. So this is just sort of some quick images of the process in action. We've outlined our planting areas. You see that there's these environmental layers that are being used: elevation, water flow, sun exposure, but then you have some sort of designer focused layers, like we want certain color plants in certain areas. We want plants that have clonal, that grow clonally in different zones, shrubs in certain zones, and you can sort of draw these little boundaries and little circle areas or geometry in plan view and sort of restrict where certain plants are going to add those sort of layers to the analysis that's going on. And we have ways of sort of visualizing these different layers too that you'll see once we jump in, how these sort of can be used to overlap in different ways in plan. And then we sort of ran up this example, sort of a fun way of seeing. We ran this sunshade analysis image in the background, and then I just created 3 different plants that have 3 different types of solar preference: shade, partial shade, and sun. And you can see that they're all sort of arranging themselves according to where there's more sun or less sun, using just simply one constraint for the plant. And that's sort of how our first example goes as well. But there's all these different, a few of these are sort of embedded within the plants themselves. It will actually read out some of the plant constraints, and then it can do things like co-location, clustering. Some plants like to cluster, and self-spacing. We'll have examples of constraint mapping where plants that are taller are towards the center of your planting zone as well. And then we also have some examples of pattern filling, which is you can use your own pattern that you generate, a pattern of points using native grasshopper or grids or things that you've created in Rhino. But in our examples, we're actually using the LandKit paving kit tools to create a pattern and then using that pattern as our layout for the planting design. So that's some pretty fun stuff that you'll see once we jump into things. And we will go ahead and do that. So we are going to start on module 1. We highly encourage you all to open up these files, follow along, see what's going on, shift things around yourself, see how things are changing and moving while we're talking, and use sort of your tests while you're following along as a way to also, if you run into issues or something gets confusing, feel free to just ask the question. But I'm going to run through the Grasshopper first and talk about sort of what's happening in the workflow of the Grasshopper script, and then we'll transition over to looking at what's actually changing in the Rhino environment. Oh, go ahead.
I have the same question Laura does.
Yes, I believe there should be a link in the original workshop prep that was sent, the email this morning.
Yeah, I'm sorry, we didn't. This is one piece we probably should have made sure everybody had stuff downloaded. So in the event, there's like a message there, and at the bottom it says participant link, our participant package. Sorry, if you don't see that, I can copy that into the I should have copied that into the.
Just right off the bat,
Yeah, it might just take a second here, Ben, when we're getting everybody started up.
Yeah, that's no
I
worries.
see it now. I see it now.
All right. I'll also share it here just in case,
Cool.
just for convenience. Yeah, so basically you're going to want to open, there's only one Rhino file. You open that up and then you can open the planting module. The one thing you want to make sure is that the pro version is working for you before you, because we do have a few pro components happening here. There's a lot you can do with PlantKit without pro components.
Yeah.
There's really, it's the one that you can do the most without pro components. But we just kind of, we didn't want to have any restraints here. So we just sort of are working that way. Ben, if you show like the PlantKit tab there.
Oh, yes.
Just so people can see that, yeah, those little red dots, if you see those, then you know you have the pro components there, and everything should open fine. Well, there's one other thing that you have to fix in the script when you bring it in has to do with
I can show them that once they get to it, but it'll be up here for the CSV input data. But essentially, you just need to make sure that your file path for where the CSV is located for the plant list, the PlantKit demo. Make sure you use the PlantKit demo CSV for this, so that things run a little bit smoother for you. But yeah, if you can let me know, Laura and Justin, when you'll have that downloaded and up and running, so that make sure that you all are able to follow along too. I don't want to get ahead of ourselves.
Yeah, I'm okay over here.
You good over there? Cool. You good to go too, Laura?
I'm good too.
Yeah, it's downloaded. I'm just opening the file now.
Okay,
Thanks.
cool. Awesome. So again, feel free to follow along and looking at the grasshopper with me. Also too, if you can't if it's a little grainy and you can't see what's going on, let me know and I can zoom in a little bit further. I'll try and keep pretty close to the page here so that it's easy to read what's going on. But we're going to start here at the very beginning of the script in the create environment. So like I mentioned before, there's sort of two main elements that you're bringing in here. Your sort of plant list and then your environment, which also eventually includes your planting areas. So looking at the environment here, you can see that we're bringing an environment boundary, and this is just a two-dimensional curve that's a closed curve. It can be, we generally use rectangles or squares or whatever, but the idea is that you have a boundary so that you can limit where the analysis is taking place. If you have it, did you have a question, someone? I heard myself or someone come onto the, maybe not. Okay. Yeah, so if you have, this gigantic site and you're only doing planting in a specific zone, or you want to focus on planting in specific zones at given times, you can have a boundary that limits where your analysis is taking place so that things are not exploding on you when you start to run these scripts. It can be pretty heavy if you start running them on gigantic sites with tons of different planting areas and hundreds of thousands of plants. But in addition, what's coming into the beginning of this create environment is your topography. And we bring this in as a mesh. You can convert it to a mesh really easily in Rhino too, if it's a BREP or a surface. We have it sort of set up here just for you, just in case you're bringing it in as like multiple meshes or multiple BREPs or surfaces that can just join together really quickly. And that's just your basic topography. It's not things like trees or buildings or anything like that. It's just your ground plane that you're working with. And then that combines into the create environment component. And you give it a cell size, and we have a default of 5 feet. And again, especially for Ishan, since you're in South America, you don't have to worry about units. It will actually read the units of your Rhino and convert them for you. So these defaults might look different if you are starting in meters or some other unit.
Yeah. So if you were to literally drop one onto your canvas, it would say it would say whatever, 1 point whatever meters. It'll be 5 feet, but converted to meters, right?
Yeah.
Or converted to millimeters or whatever it is. And so the only hitch is that if you may have a little bit of a challenge here with the examples that we're providing. So I would just, if you were to just bring them right into, using them in meters. So I would just pay attention to things like that if you do want to translate them for your own templates or workflows, right? So you may just have to
I'm working for a US firm and everything is in the US, so it's all in feet.
That's right. You're just working remotely. But anyway, it's good for everyone to know that it will do international units. Like we were working in TopoKit and we got going and we had done it half the thing before I was like, oh my gosh, the international units are working brilliantly now. We were in hectares or something, or meters or something. I forget what it was, but it was something different than feet for sure. And it was working great. We've integrated the whole workflow to all the kits.
Yeah, so it should be fine for all of you. But the cell size here allows you to adjust that sort of the value. So if you are working on a gigantic site and you're trying to be sort of more general about your planting, or you're trying to do something a little bit more general at the beginning, increasing this, spaces out the points for the analysis so that you can, maybe if you're dealing with a larger site or if you're just trying to get some general planting down first, you can increase the cell size so things run a lot faster. And then once you sort of figure out your parameters and rules, you can decrease the cell size to create a much higher quality, more points on your site so you have more plant placements. But that's something to pay attention to when you're setting up a plant kit script. But moving on from the create environment, so out of it, you see that it's just called an environment. This value is just simply called an environment, but embedded within it is all of the data that you're feeding into it and adding to it as you go along in your environmental analysis steps. So this environment instance has within it our topography and the boundary where our analysis will take place. And for the first module, for the first example, we're actually running sun exposure analysis. So some of you may be familiar with Ladybug. A very nice, wonderful person developed all of these environmental analysis tools and gave them to the Grasshopper world for free. Thank you. Chris has nicely packaged this up to be used very easily and fluidly with the plant kit sun exposure analysis component. So basically what we're doing is we're taking our environment, we're feeding it down into the environment input, and the output is also just an environment. But it's adding the sun exposure analysis into it as well. So we have our vectors here coming in from our Ladybug package, and we're in Philadelphia. You enter your longitude, latitude, your time zone, and then we have the start and last, which is the starting month and the last month from 1 to 12. So we're doing a March to November growing season here. A couple more things to note is you also have to input your start and end into the sun exposure analysis component. And in addition to that, we have a convert tool here that allows you to convert between the text of saying the number of hours per day a specific location is receiving sun. A 0 to 3 would be considered shade, a 3 to 6 is considered part shade, and 7+ would be considered full sun growing area. But you can actually convert these back to just number values if you want, if you're doing something a little bit more specific on certain plants. And then the last input that you're seeing here is the other meshes is what it's called for casting significant shadows. And this is the spot where you put in things like buildings, trees, other vertical elements that are going to affect your sunshade on your site. So currently we have a few buildings coming in and a few trees. And really quickly, if you haven't seen this component here, called the pipeline, it's called the geometry pipeline. You'll see this throughout the modules. For those who don't know what it is, maybe all of you do. It's a native Grasshopper component that essentially allows you to feed live information from Rhino related to a specific layer. So this is under layers section 1, sublayer environmental layers, sublayer buildings, and we're bringing in BREPs, so BREP type geometry And if I add any geometry to that layer, it will automatically update this geometry pipeline. Or if I shift something around, it will automatically update it and then feed it back through and then reprocess the whole plant script. And I'll show you that when we move around a few trees for fun, so you can actually see that working live. So out of it comes your environment, and currently we're only adding one layer of environmental analysis to our environment. And we have a visualization around here, down here, which I'll show you once we get into the Rhino itself. But the next step that comes along is you're feeding that into a create planting area component with some closed boundaries and the environment. And what's coming out is area instances. So these are just closed curves that represent where our planting zones are. And they're just two-dimensional curves on the zero Z planar. And what's coming out is 4 different areas, because we have 4 different planting areas being fed in. And each of these areas have within them embedded the environmental analysis appropriate to those planting areas. So if you shift around the planting areas, it will change, within that area related to the environmental analysis that you've done before. So you analyze the whole site, and then you locate the zones where that environmental analysis will actually be used in your planting areas. So coming out of that, you have your planting areas, and then the sort of the next step that you have to do here is you have to feed in your CSV information. So this is where Chris was talking about the one thing that you're going to have to change when you open up your Grasshopper script is you'll have to change where the file path is coming from. So if you're using, this data here, you have your participant package open, you go into data, and here's our plant kit demo CSV. If I click up here and just copy this and drop it in here, I'd have to add a backslash and then add the full name with the file path in it. So plantkit demo.csv would go in there as well. And if you don't put the .csv, it will confuse you and not work.
One other way that, and I've started doing this more often, and this is maybe just left over from the way we've done it before, but you can also add a file path component. And then you could just search for the file. So if you, if you then right click and say, look for that file, add the file, and then you can literally go to the file and pick that file to use. So,
and then you would just plug that straight in here, and it would have your file path.
Yeah, exactly. But the text, one of the reasons we like the text is because it shows us whether it's Chris's link or Ben's link.
Yeah, helps us see it really quickly
when we're working on it together.
But I also want to show a couple things of what this create plants from CSV data is doing and what this component has the power to do, even though we'll be talking a little bit more about what you'll be able to see what they're doing a little bit later on as well. But you can see that I have my CSV path here, and you see it's automatically pulling in my 19 plants that I'm using for the tutorial. So I'll open this up. I'm actually using Open Office right now, so hide everyone. So we have the CSV just processed up here, and you can see that it's actually reading our plant species names and calling each of those plant species by their scientific name. And that's because our species key down here is defaulted as scientific name. So if you have a CSV database and you have if you have it titled plant names, you could just plug in a panel that says plant names that matches the title of your plant names, and it will actually use that instead of scientific name. So this is a quick way to sort of adjust it to your own CSV and plant database setups. Another couple things to note here is that you have a names list, which allows you to input. You can actually manually input specific plants that you want to pull in out of your plant database. So we'll actually just find those plants by their name, scientific name, or whatever title that you have, and just only bring in those plants that you've specified. You can also limit the number of plants that you're pulling in out of your list. So if I only want to bring in 5 plants instead of all of them, I could enter in the number 5, and it will limit the list down to 5. And you'll see it's just going to grab the first 5 plants in the list. And now the reason for that is that we have this random toggle down here. And if I hit true, it will bring in 5 random plants instead of the first 5 plants. So we keep this at false just to make sure that we're bringing in plants in order just for visual purposes. But when you have big, long lists and you're just trying to do a quick test, sometimes it's good to just limit the number of plants you're bringing in and bring in a bunch of random ones just to do some tests. So what's coming out is each of the different plants, and I'll kind of show you really quickly what's coming out of that first. So the main thing that's coming in for each of the plants are these different attributes and the values for the different attributes. So it's reading the CSV file and it's finding different pieces of information that relate to the embedded. So these attribute keys, these are the sort of the embedded plant kit plant data, the constraints that are just embedded within the plants. Things like color, height, you can even do height min and max, radius of the plant, whether it's self-spacing, the species name, and then also this W value, which is a weighted value. So that's kind of handy because if you have 5 different plants that fit within a specific location, if you give one a higher weight value, it will use that plant over another and so on and so forth. So it's a little bit more technical, but it's something that is available to be used if you need it. But you'll also see down here that the plants, it's actually reading the plants different values that we have that are not sort of embedded within the plant itself from the CSV. So things like soil moisture preferences for this specific species, its phytoremediation value, which is just a random value that we've added in. Its spread, its sun exposure preferences, the months that it's flowering, slope preferences, things like that are actually coming into the software from the CSV, but these specific traits, the data keys here, are actually not being applied until we specify them using a add niche component, which is what you're seeing here. So coming out of here, we have this apply niches from data component, and we're specifying that we want the field of sun exposure from the CSV to be applied to the plants. And you'll see up here that when we actually analyze which niches are being applied to the plant for the analysis, you can see that all the plants have a sun exposure analysis constraint applied to the plant, and then their sun exposure preferences are being related to those plants. So currently we only have one niche value that's being applied, and then all of these other attributes are already automatically being read out of the CSV. So then coming out of here, you see that it's, again, just the plant with its scientific name, but that niche is applied and embedded within the plant instance itself.
Ben, that original CSV file, you manually do it, or from that website you're downloading it and all this information comes in automatically?
Either one, actually. So you could just download a giant CSV that's related to a specific zone that you're working in. So
based on the ecoregion that you said, right?
Correct. And then it has a lot of constraints and traits of the plants that are already on that list. But if your office has a CSV that you will use for planting design already, you could actually adjust some of these different titles or headers here to match the ERA database setup. Or you could just adjust the way that your plant kit is reading them, like for instance, the species key. If your internal office, like if I changed the scientific name up here to plant names instead as the title of this column, I would just need to match that up with the species key so that it will read that column and say these are the plant names to use.
Okay, gotcha.
So it allows you to use like your own custom CSV that you have in-house at a firm, or you can adjust your CSV or download CSVs from the ERA to make them work more seamlessly.
Okay, great.
We created this short list by copying some stuff out of this ERA database.
Yeah.
We have the whole CSV for the ERA. It's in the participant package. So so you can actually use that as a starting point, and we'll actually later in the demos we're going to show you how to kind of maybe like deal with more data. There's a query thing in in this that allows you to filter data out that's coming in essentially based on different parameters. Right here, right in Grasshopper. So you
Right
could
here.
have one central database for your office, and then people are filtering stuff based on the needs of their project, potentially, you know. The one there's a number of drawbacks for the ERA. Like there's a lot of missing data, is one. It's a huge database, and it's great because it's native plants all over the United States, but it has some issues. Like that's one, missing data. The other thing is that it doesn't say like what's commercially available, right?
Right.
So that's where, you know, we're kind of leaving it to firms, you know, who are local and regional to different places to kind of, you know, think about that. You know, and we're constantly on the lookout for databases and things like that. But it seems like the best sort of solution for now to kind of get people going and understanding how it works and get the juices flowing.
Okay, that's helpful.
Sorry to tangent there, but
No, it's good. I actually didn't mention the query instance because, again, Chris is going to showcase that a little bit more in sort of like the fourth module, which is just an add-on to the last module that we're doing. But it's a pretty amazing way of filtering out like a gigantic list of plants down to the ones that pertain to your project, if you have a master database that you're working with. Okay, so we'll just shift down here to how do you combine these different pieces together? You have your plants coming in with all the information that pertains to your project, and then you have your planting areas with the environmental analysis embedded within them. And that all comes together in the fill area with plants constrained. And as you'll see in another module, another variation of this that uses patterns. And you feed in your areas, your planting areas, and you feed in your plant list. And there's a few other different inputs here that are useful in different ways. Packing ratio, which allows you to like manually tweak sort of the ratio to pack mix. So it allows you to sort of pack your plants together a little bit more. But we also have some components that do this a little bit more efficiently coming out too. You can sort of control if certain plants are fixed, meaning they won't shift position when you do these packing, use these packing tools. You can toggle whether or not these niches that we're adding, these constraints that we're using, you can toggle whether those are going to be used or not for the actual plant placements. So if you just want to do a generalized one really quick, you can toggle this off and it won't use any of the constraints for placing. And then there's a buffer for distance from existing plants, which I don't know if we've even used yet, Chris, but it's something that you've embedded within it. I don't know if you want to mention it.
we don't use it too much, but sometimes if you're like just really trying to get stuff to fill in, it can be a way of like pre-culling plants out before you do the packing. It's like it's sort of 6 of one, half dozen of another sometimes, but the buffering helps it so that maybe plants don't travel as far when they pack, right? So that the buffer will help to remove plants that aren't you know, that maybe if you have a dense amount of plants in one area and a loose amount in another, the dense part won't like push the other ones too far, you know, if that makes sense. The neat thing here is you're basically designing a parachute, right? So you're placing plants, and they can either be fixed or not, and you can place multiple plants, and then you can do packing at any point as well. So like you could place a bunch of fixed plants that are like, okay, I know these shrubs are going to go here, or maybe they get placed using a different thing, and then you fix them, and then you can because you can like freeze areas as well, and then you can like place other plants and then do the packing, and it will only really pack those other plants, and the other ones won't move. They'll get packed around it. So it's kind of like you can do quite a bit of like different things by combining these in different ways.
Yeah, and I guess one way that's super applicable is if you're using PlantKit to place your trees, for instance, and you don't want those to move once you place them, you can have those be fixed and the other plants around them shift around or things like that, or like Chris mentioned, shrubs. So there's a lot of fun ways to use it. that may or may not be applicable to a project you're working on. But the tool's there.
Is the
That's important.
packing ratio the spacing? I'm confused. Like, where do you control like on center spacing?
Yeah, so that's good. So Ishan, it's a little confusing that we say packing ratio and then we have pack plants. But the packing ratio is about when they get placed, how densely are we targeting to fill these plants in? So if it's a 1, it's going to be targeting to fill the area, the cumulative area of all the plants will equal the area of your planting area. So that's a 1-to-1, right? But if it's 2, we're doubling the density. And part of the reason we double the density here is because of the constraints. We're removing out a lot of plants that aren't working. So there's a little bit of dynamism there with this more organic fill. But with the pattern fill, which we'll show you, you can provide a pattern, which is exactly whatever spacing you want. And then that spacing, it won't change. You're just placing plants on points, and it makes it a lot easier for a contractor to install.
Right.
But that algorithm the filling algorithm is a little bit more advanced, where it's trying multiple times to get different plants in a certain location. And if it tries however many times you've specified and it doesn't find anything, it will show you which points did not get filled. But it's a lot more persistent at filling the list that you have into that pattern. Whereas the organic fill, it's harder to control in some ways, because you might say, I want all of these constraints, and I want you to place all these plants, and it might say none of these go anywhere, and you just, it's a way of seeing where things go and where they don't go, honestly. But there are ways of trying, like, successfully packing, and we'll show that a little bit more in a later example.
Module 2, maybe a little bit more.
Okay.
What we should really do now, Ben, is show them what it actually looks like.
I know. So I mean, that's basically the gist of what's left over. So you can use the a couple different components to just visualize it. But I think it's good to just like now jump in and like see what's happening a little bit. So I actually have this the sun exposure visualization on. It's just a little script that we wrote that takes the different points. So you can actually see here's the grid of points that are that cell size that I was talking about. So these are the points each of these points are being analyzed in their environment to find, like, what are the conditions on this specific point. And then we're just sort of visualizing where the sunshade is taking place. So you can see that the darker, the black areas are where it's considered shade. The purple is considered part shade, and then the white is considered full sun. And you can just see, like, really easily and really quickly that there is sort of a different mix of plants taking place in this shaded and part shade environment. But you can actually shift this around too. So let me actually just jump into this view. And you can see that I have these meshes here. These are our trees that I was talking about that we were using. But we can actually just shift these trees around and watch it live, update, change things for us based on the changes in the sunshade analysis. And sometimes one tree is not quite enough to get a little shade, but you can see now I'm creating a little bit more part shade in one area, and it's changing the plants that are being located in that specific zone. So you're welcome to, like, shift these trees around, copy them, make more, and sort of see what's happening. But this is like sort of the quickest example that we showed in the presentation too, that you have a piece of analysis, you have plants that have a preference of sun, shade, or part shade, and they're locating based on where that sun, shade, and part shade is taking place from our analysis. So it's kind of fun to just shift them around and, like, see where the plants are changing and getting more shade or less shade, and you can sort of build up a different mix of plants here. But
hey, Ben,
yes.
Will you try one thing for me? Go over to where the trees are going in, those tree meshes. No, in the script there.
Yeah.
And do, just like we have the join into one mesh for the topo, do a join into one mesh for that as well. And just watch when you plug it in, watch how fast, see if the timing of the sunshade changes.
Like
Yeah, it's
5
pretty much
milliseconds faster. Not bad.
pretty much the same. Never mind. Sometimes that can speed things up, you know, by only having one mesh for it to actually be shooting vectors at.
Process.
So it's just, yeah, something I had noticed when you're going through, and since you were doing so much of that now, I thought maybe it'd be a good time to update it.
I bet with a lot more layers and trees and different and much larger site and smaller cell sizes, that makes a much bigger difference. A little cheat there for you all. But yeah, this is just a quick example to sort of showcase very quickly, like, and simply, that you have an environment that we've created, you have a specific niche value of each plant's sunshade analysis that we've applied to it, and then you're seeing the plants actually responding to those environmental conditions live as we're changing things around and updating things. But we'll go ahead and shift on to module 2, unless you have something you want to mention about this, Chris.
Well, I was just going to say, like, you know, I would just encourage people to like move the tree around,
Yeah.
try changing the plant boundary. You know, there may be some parameters that you could adjust. Like you could, it'll probably take a few seconds to process, but you could turn cell size to 1 or 4 in the create environment to see like how that affects. But the neat thing is, it's, you know, I know it took Ben like 30 minutes to explain the script, but once you have that script set up, you can change all these parameters, like, and you're not going back to square one whenever you're trying to, you know, when you're trying to refine something.
But like I deleted a planting area and it automatically updated the script and removed that planting area from where things were being planted. But if I extend this planting area out, you'll see that it goes beyond. There's no more topography for it to hit. It doesn't have any more analysis on the edge there, but it's still going to process everything that's within these planting areas as you're going. So I can just change around. The planting areas do not have to be rectangular. You can make them curved or all different types of shapes. And see the.
I have a question about the pattern in which everything gets planted.
Yeah.
We've created one at our office as well before, about a year ago, that worked with hatch patterns, and every intersection of the points we were essentially placing it. However, one thing I was never able to really figure out was to adjust the orientation to run perpendicular with a road or a path in front of it. Because right now you can see that the patterning is all kind of oriented to X and Y, the world, rather than, is there a way to have the individual planting orient differently with the same pattern, like follow along a spline?
Yes. So one thing where we actually we haven't talked about a whole lot, very much, honestly, in the last year, is that first, I should highlight here, there's this first component here, and that component will allow you, given some locations and some plants, you can place some things uniquely just in these locations. The pattern fill does something very similar, but this is meant for like discrete plants. So you can set up actual, just like this plant and that plant are literally going to go in these locations. So you can be really explicit. And this is a way to kind of set up exact, you know, design moves within something that you're going to then fill in larger ideas.
Well, I wasn't really referring to the plant itself. Okay. I was referring to the patterning. So let's say we have a triangular spacing of plants, but in this current scenario, this triangular spacing is going to be only relative to the world in Rhino. So everything is going to be straight up and down. I wanted to essentially rotate according to the nearest path to it. So if the path maneuvers around and goes from west to east, now turning to north to south, will the rotation of the planting boundary and the pattern rotate with that path? Is there a way that you've had that within the code to allow each planting boundary to have a different rotation for the pattern?
Yes, you could. So that this is where it's the beauty of the fact that you're in Grasshopper, where that's actually a really, really easy thing to set up in Grasshopper. You just basically, you take your path edges and you do a serial offset and we don't have to go through it now, Ben, but you
Yeah.
would do a serial offset of those path curves, and then you could subdivide those curves into points. That set of points you could use as your pattern to do your fill, which we're going to show you this pattern fill in the next. What we're looking at here isn't really a pattern. This is more of like an organic fill, but we do have a pattern that we're going to show you in the next module. So that's like maybe a great transition moment for the next module.
Yeah, but essentially what you're saying is if you have this sort of rectangular planting area, you explode it and grab one spline and then offset that into the planting area and then divide the points, you have sort of a grid that's created from the planting area that would be your pattern that you would use. And then if you rotate this, it would still offset it according to that. Is that essentially what you're saying, Chris? But
I think so. That's what I'm saying, but
yeah.
I'm not sure if that's what Justin is asking.
Yeah, I guess that's the question, if that answers Justin's question.
Not quite what I'm asking, but we'll wait to see the second module. Maybe it'll answer it.
I think it'll help a lot to see that. For sure.
Hopefully it helps a little bit, yeah. So we'll shift over to section 2 or module 2, section 2 in the Rhino, module 2 in the Grasshopper, which probably something we should update, but that's okay. You'll see a very similar, again, Grasshopper script. Same general idea. It's running. Oh, okay. Yeah. Thanks, Nate. He's already gone, I think. But you'll see a very general, similar Grasshopper script running here. It's just we're now using a few new things that I'm going to showcase to as we're going through and just sort of point out right off the bat. And the first one is what we were talking about before as well, Justin, the fill pattern area. So down here, you can see that we're taking the boundaries of our planting areas. And I don't know if this is, can you all see this? I hope if you can, just let me know. We're taking our area boundaries, and we're feeding it through a paving kit script of adding pattern to area. We're creating a custom pattern that represents a grid, that's not the best way to visualize it. It's creating these little grids of points using our paving areas as our planting areas as our boundaries. And then that is being fed in for a pattern. So we're actually creating a pattern for each of the different areas. And you could actually use Paving Kit, I think, to answer maybe the question that you were asking before, Justin, is that you could actually create a paving area for each of them and then also use the rotation element within this to rotate your grid or your pattern if you didn't want to do it with native Grasshopper components.
Yeah, or a series of offsets of the boundaries of your planting edges, and then using those offsets and then subdividing those in order to get rows of planting that go along the edge.
Yeah, the rotation seems like that might be the answer, especially if everything can be grouped beforehand and each one have its own new rotation axis to orient to a new this midpoint of the spline.
Yeah,
there's a number of ways to do that, and it's like computationally, so that you maybe you define your areas with surfaces, and then it's actually literally the surface orientation before you trimmed it, or we've also done a thing where we'll just draw a line that helps us get an angle for each one, and so you just use a little bit of Grasshopper to capture the different lines within each one and say what's the angle for that one, and just match the data, so that then you can plug the angle in and the area in, and you've got like a set of both, and then it will use different angles for different areas. I know that's probably a little confusing, but we could help you with that too if you want a little assistance on that setup.
Yeah.
No, it all makes sense. The rotation aspect is where I think I'd plug it most likely into. And for what I want, it'd be basically finding the horizontal prep frame along the center line of the path, and then finding the closest prep frame to the area of the boundary, and then finding that rotation, how to rotate from the world to rotate to that prep frame.
Cool.
That makes sense. Cool. Well, also just generally, I want to show a couple more things that are happening with this fill pattern area. As Chris mentioned, the fill pattern area, there will be locations that will not be filled. And you can see that when you're looking at this sort of setup here, and I'll turn this on so maybe it's a little bit easier to see these blobs and this other visualization. I'll talk about the first example you saw in a minute. But in some instances, you can see that there's this like grid pattern taking place, but then there's these gaps in between. And those gaps represent what Chris was talking about, where some plants are just not going to fit in a specific location. And this component will try, it uses these tries, so it will run through the process however many times you specify to try and find the best plant for that location. So if I increase this value, we can see that there's about 215 locations in our total planting, in the planting areas that we're using, that are not being filled. But if I increase the number of tries, looks like a few more plants got in, and there's only 98 points that are not being filled. So this is that input parameter that allows us to control how many times is this going to process the planting areas and the locations to find the best plants for each location. So this is something to pay attention to when you're using the fill pattern area. That's not as applicable when you use the more organic fill pattern or fill area with plants constrained. And then some of these other inputs are also matching what you saw before. But you can still use the plant packing as well with this component. So you can see that we have these little gap spaces in here, and maybe we want those to fill in around a little bit more. And we can plug that in and see the plants shift around a little bit. So that block preview. So that we actually fill in around there a little bit more in those different locations. You have a little bit more even distribution around the planting areas using that packing plants. Go ahead, Chris.
Yeah, I think this is like a great way, just with our experience over time with dealing with contractors and everything else. This is a great way to like think about maybe large shrubs that would get placed, but maybe not a great way to think about ground covers. Because if you were to give this ground cover plan to a contractor, they might just like laugh at you, So we like this organic thing. Like the organic packing works well a lot of times, but it's sort of like, what's the right patterning for the different species, and like what's reasonable for a contractor to install. And it's just something to be aware of when you're designing, and we feel responsible to like mention, because we don't want to be like the byproduct of a lot of disappointment, and like, oh, okay, we can't build our project now because we thought we got overly ambitious with like what we thought a contractor would actually do. So it's like one of the reasons we like the pattern is because it's a much more rational thing for someone to lay out. But we do know that like sometimes having more organic stuff is nice if you're doing a bunch of clustering of shrubs or something. And so you might actually combine these different strategies for different layers of your landscapes.
Yeah, or even if you just think about with the organic fill, you thinking of the different nodes as mixes of seed or something like that. So you could actually use it to say, well, this zone is going to be this mix of seeds when you see the planting zone. So there's lots of different ways you can think about how to use the organic in a way that would be easy for a contractor to fill in. But for much more prescribed planting, the fill planting area with the pattern is definitely a much more friendly approach, we'll say. But I'm going to jump back here and show you a couple more of these analysis tools that we're using. One in particular, there's one in particular called the add slope layer that we're seeing back here. And you'll see it's a very simple component. All it does is it analyzes the slope of your topography and then adds that into your environment as an analysis layer. So it's adding the slope analysis into your environment. And then you'll see here too that we've added what's called an add shape values layer. What this allows us to do is to specify a name that this environmental analysis will apply to. And we said we want these pieces of geometry will be related to soil moisture. And I'll show you how that is looking in the Rhino 2. I'll open this up. But essentially what we're doing is we're feeding in like a few pieces of geometry, and we're feeding in the values of these geometry. And you can see here that the values are dry, moist, and wet. And so those are coming directly from section 2, site constraints, soil moisture. We have wet, moist, and dry soil locations. And these are actually, within each of these layers is a piece of geometry that relates to the soil conditions, soil moisture conditions on the site. So here we have a boundary that represents the wet soil. Then we have 2 boundaries here that represent moist soil. And then we have this overarching boundary that represents the entire site of dry soil. So one lovely thing about this too is that PlantKit will always start from the largest boundary and move smaller. So if your whole site is dry and there's specific locations that have certain types of soil moisture, you can make the whole site with a boundary that's dry like we have here, and then these moist zones will be processed next. And then since the wet zone is smaller than the moist zone, it will be processed last. And you can actually kind of see a reflection of where those different types of plants are placing. These blue plants clearly like wet soils. So within this zone, you have more of these blue plants and less of the other colors. And the moist zones, you have more of these yellows and reds that are coming in. Go ahead, Chris.
Yeah, maybe delete that wet zone and just show people,
Oh, yeah.
how quickly that changes. So, it reanalyzes and then boom, different soil conditions, different plants. The other thing I wanted, since I'm talking, I'm going to mention that you may have noticed this, but these layers of analysis can have all kinds of domains, right? So they can have a range from like 0 to 20. They can have a number like 5. They can have a word like moist or sunny. They can have a color. So that there's actually a lot of different domains that you can create within these constraints and within the analysis layers to compare against, right? So that's kind of neat. And really, if it's a word, it's just going to match the word. And if it's a color, it's going to try to match the color. But there's also a thing called a cushion, which Ben will talk about, that where it's like, if it's close enough, it will get it. And then, obvious ranges probably, are sort of obvious. It's like if it falls within the range, it will work.
And how you relate those back are, you're basically creating, geometry that relates to a specific name in your CSV for a specific plant constraint. So you still have to bring that plant constraint in. So here we have soil moisture. The name of this matches the name in our CSV of soil moisture up here. And then we're, in addition to the sun exposure now with our plant CSV data that's coming in, we're adding another niche, the soil moisture. And if you look up here, you can see that now our soil moisture is coming in. Oh, we didn't have that visualized there, that's okay. But you'll see that the soil moisture that's coming in is being applied to the plant, and the soil moisture preferences are being, since they're text as wet, dry, and moist, those will relate directly to the different layer name conventions that we have in here for wet, dry, and moist. And so that's how the plants know. It's like, look for the layer, look for the name of the constraint, and match it to the shape value layer constraint that you've applied in the environmental analysis layer. And again, you can do this with all kinds of things: fragrance, pollinator values, anything that you want that's text or numbers or domains.
Yeah. And also, this is a great moment to mention that this doesn't have to be plants.
Yes.
You could place all kinds of, you could create databases of all kinds of things, uses on a site, uses in a city.
We did test that recently. It was cool.
We've been testing that with a few projects, like trying to figure out, like, where a good comfort zone is for, entertaining guests or something, on like a residential site. Like, so there's so many, uses you could apply to this. You can plant all kinds of things that don't have to be plants. And like Ben said, you could be planting whole zones of plants where you're sort of saying, okay, this whole area that you maybe create species that are like mixes in and of themselves. And you say, okay, this whole area is actually going to be this seed mix, or this whole area is going to be this, and maybe it's a way to handle much larger planting installations potentially, you know, in a computationally reasonable way.
So I'm going to jump back over to this preview, but or actually I'll stay in the plan view because I want to show you this block thing that's going on too. It's kind of fun. So
the slope attribute is
the slope attribute's the other one. That's actually a good one to talk about. So you saw that we are bringing in this add slope layer into our environmental analysis. So why did we bring that in is the question. And I'll switch back over to this other view here so you can kind of see it. But we've created this little platform over here. Sorry, I'm just going to jump around for just a second to turn this off. You can see we have a little bit more topography here. We have a slightly steeper slope and then a consistent slope, and then it levels out. But something you'll notice is that a lot of the plants that are surrounding this steeper slope are just these white blobs. There's not very many of these other like smaller red plants there, or the yellow plants that also work within the same conditions. And what we're doing is we've pulled a specific plant species out of our list using this merge plant niche component. And we said we want to find this plant species, and we want to add a niche value to it that is related to slope, and that it can work on a much more wide range of slopes, or more particularly steeper slopes. And so we've added this in as a niche value, and that's what this white blob plant is it's the only plant that has a slope value that's been applied to it that will work on a steep slope. And so that plant is being located in the steeper slope location. Go ahead, Chris.
But the neat thing about the component is that you're putting in the whole list, and then you can just have the plants that you want to have those new parameters. It applies them just to that plant, and it spits out the whole list again with the one plant modified. So you're not doing the grasshopper thing where you're like trying to pull that one plant out and do the stuff to it and then pull them all back together. You know, it's like, yeah, it's a nice way of, and then you could also treat things in a more computational way where you process a bunch of data from one column, and you're actually transforming that and saying, okay, well, you know, the spacing is going to be based on the height of the plant or something like that. And you can kind of do more computational things this way as well. And the merge niche is a way of like, essentially the idea is that the plant always has a niche, but you can create a niche and merge that in. And you know, kind of, you're always going to end up with one niche for the plant, which is the whole set of constraints.
Yeah. So so as you said, like you can see that the plants coming out of the list and the plants going in the list look the exact same. It's just that now this one species has embedded within it that niche layer that's being applied to it, which the others do not have, even though they all have the sun exposure and soil moisture applied. So that's being processed through. We showed you the fill planting areas pattern. So I'll show you the sort of block preview output that we've added to this tutorial. That's pretty fun. And then also show you the plant schedule, the first view of the plant schedule. So this was the first view that you saw where you see these, they look like CAD block plants and trees. So that's actually being processed from this nice, lovely grid of blocks that Chris made generatively using some fun Grasshopper scripting. And these are all custom. You all can use these for whatever you want to, if you want.
You're welcome.
Thanks, Chris. We were definitely thinking. But what we're doing is we're basically just using those symbols coming from here as it's sorting through. So here's all of the blocks that we're bringing in, and we're relating the random block to a name of a block, and then using that specific species. So each species has a block that's related to it just randomly using this script. And then that block, that CAD block, is being placed on the site for that specific species. And the fun part about it is that that's what this little script right here is doing, is it's basically applying a random block to a random species and then using that species throughout. But if you actually create a block and name it according to the species, you could just plug the species into the name of the block here, and it will actually find the name of the block that relates to that species and then just use it. So if you have a specific CAD block that you like to use for a specific shrub, just name that block in Rhino the name of that species, and then you can actually just cut out this whole chunk of script here and just have it apply straight across. So that's a fun little part there, and you can see how it's placing all of those sort of, it's placing them at elevation, but in plan view, you can see all of them. It's super handy for your, your documentation for your planting design. And you'll see in module 3 how that we can actually bring those symbols down into our plant schedule as well, which is basically you just feed, for the plant schedule component, you just feed it a starting point, so a location where that plant schedule will be drawn, and then you feed it your planting areas coming out of your fill pattern constrained or your just fill planting area constrained into it, and you get locations, you get the number of plants, you get the name of the species, you get the symbol that is being used for the plant. So in this scenario, we're using just the generalized symbols, but you'll see in the third module that we're actually applying the blocks that relate to those species to our plant schedule too, to just sort of make that whole process a little bit easier. Another fun thing about this is you can actually toggle whether it will include the plant niche values in there, so that you can actually visualize which plants have which different types of niche values. Grasshopper seems to be freaking out just because I created a Boolean toggle. Have you run into this before, Chris, with your grasshopper? That's fun. And there you go. Now you can see that the number of plants, the soil moisture preference, the slope preference, and you can see that only that one species that we specified has a slope value, and then the sun exposure. So you can toggle this on and off if you want to showcase some of that stuff. Okay.
Or just turn it on, because like we always think about all of this as this process of exploration, like what plants work, what rules work, how does this all, and because it's an iterative process, like the schedule here isn't just about like, oh, how many plants do I have? How many plants do I have to order? It's also about like, okay, what's happening? Like it's for you to help debug yourself, and like figure out what, oh, okay, I'm assuming that these will work here, but yeah, etc.
Yeah, I agree, Laura. Very much does. Yeah, and then it kind of flips that idea of how we approach previously, would approach planting designs. We're trying to figure out all the details in our head and then do something. But in this way, we're kind of like setting up the process, doing something, and then figuring out if it's doing the things that we need it to do, and then adjusting and fixing the inputs. So it just reprocesses for you. I think that kind of covers most of what's in this module. And again, I would definitely encourage you to like shift around some of these trees if you want. You can change the planting zones, kind of see how things are shifting and moving around and changing. Add some more soil moisture zones if you want, just to see where plants are being created and how the planting design is changing according to those added analysis layers. But if everyone's sort of like in a good place, we can sort of jump into the third module, which is going to be a fun one too. So in the continuation of our wonderful transect from planting beds up a hillside, we're now in the urban environment, where we have a few more buildings and a road. And you can see that we have, some familiar elements of planting areas, and we also have some soil moisture zones as well in here for wet and moist. But there's a couple things I want to jump to here really quick. First thing is coming in for our plant database. You'll see that we've applied fragrance as a niche value as well. But we've also applied flower color as niche value. And I believe Chris mentioned a little bit ago about having this thing called a cushion in your in your niche values in your domains. So when you bring in, it's probably easiest to understand with flower color, because when flower color comes in, it comes in as a word or an RGB value. And one fun thing that you'll notice is that if you go to the plant kit demo CSV, you'll see that our flower colors are all named with text values of red, white, yellow, and blue. But you'll see that when they're coming into plant kit, they're actually being translated into RGB values. So plant kit has embedded within it a way of reading text and converting it to an RGB value. And we generally recommend that if you're going from text to color RGB values, that you add in a cushion in order to ensure that you're sort of capturing a wider range of that color. So that if you have something that's a little bit off red, it will still apply it to the red value of your colors, unless you're trying to be very specific about those different color values. But we've applied a cushion of 100, so it's taking these values and adding a sort of 100 range on either end of each of these values to capture the different block colorings that we're working with. So that's what this is doing down here, is we're doing the same process of just applying niche from data. We're getting the niche info. And yeah, there, Chris just dropped a little helpful tutorial for this in the chat, so that it's a little bit easier to understand and see.
It's just a reference page kind of relating to some of the data items within within plant kit and how it reads data. And one of the things there very prominent is all the color names that it will convert. So if you have requests, let us know. We'll add them. But this is what was in USDA. Yeah.
So again, sort of from that eco-regional, or I guess it was USDA, not eco-regional vegetation application. So yeah, if you have some odd flowering colors, just pay attention to that and use the link there as reference so that you can not get picked up. But again, what's coming out is just our full plant list of 19 plants with these new niche values embedded, the fragrance and the flower color. So in the same way that we were doing soil moisture before, we're using the exact same process for flower color actually. So if we go back here to our analysis layers and zoom in a little bit, you'll see we're still adding the soil moisture, we're still adding the sun exposure, but then we're adding in also these shape value layers that are referenced to fragrance and flower color. And then we're using these native, these plant kit pro components that will take an input layer structure from Rhino, and it will pull out the geometry from those layers. It'll pull out the values of those layers and then the layer colors as well. So under design constraints here, we have flower color. So flower color, and we have white and yellow, and you'll see that these values, if you hold your cursor over top, the values that are coming in are the RGB values for white and yellow, and they're being associated to the curves that are associated in these layers. So we have a white lit curve here, and you'll see that other than these pink nodes, all the plants within this boundary are white. And I'll show you what those pink nodes are right after this example here. And then we have this yellow zone right here, which only has yellow and these sort of odd filler plants that you're seeing. And I'll go ahead and jump ahead and show you exactly what those are doing now. So you can see that, we also have this fragrance layer of whether a plant is fragrant or not. So if you go to the CSV, go to the fragrance column, you'll see that it's just listed as fragrant or non-fragrant for each plant. We're basically saying if the plant is fragrant, it can be placed inside of these zones. And these zones are made sort of to surround these trash bins that I put inside of the model. So we have some trash cans and we drew a little circle around them that represents the smell that the trash can could cause. And we want to put fragrant plants near the trash cans so people don't get off-put by the smells, which if you live in a dog-heavy area, is super helpful. That's where I live. I'll come back to this in a moment, but I'll jump ahead and show what's going on here with these little pink plants that seem unusual. So we have this component here. So you'll see that we have first of all, you'll see that we have two fill area pattern constraints, one right after the other. Seems very strange, but we've also created a plant custom. So this is a fun thing you can do too if you're just trying to quickly create some plants, or maybe you don't want to go through a whole CSV, you just want to use a single plant for some reason, or a couple of plants. You can actually just specify a name, a radius, a color, a height, whether it's self-spacing, if it has niche values, you can add into it, cluster radius. And we've created this single plant that we've called the generalist. And we have used another fill area pattern constraint. And we've taken all of the points out of this pattern that are not being filled from the previous pattern. So we've run the original fill pattern constraint, and out of it, we have about 398 locations that were not filled with plants. And what we're doing is we're saying, okay, fill all of those remaining areas with these generalist plants. So we added new plant list. We added in our planting areas that already have plants located in them. And we've added in a new pattern, which is all the remaining points that were not filled before. And we've basically turned off the constraint. So none of the environmental constraints or the plant constraints are being used to place these plants. It's just automatically placing this plant on those locations. And so that's why in the yellow zone and the white zone of the flowering plants, you're still getting these pink plants, because it's not using any constraints to place the generalist plant. It's a filler plant or a ground cover that we're using around everything. And again, if I increase the tries here, from 10 to 30 perhaps, it will try to fill the original pattern more, and it will leave less locations, ideally, for the generalist plants. So you'll see a lot more yellows in here, a lot more whites in these zones, and you'll see that instead of 398, now we have 261 remaining locations that were not filled. And again, being filled in by the generalist plants. I'll decrease this down to 10 just so it moves a little faster. And then I will go into a 3D view. So you see we're still using these block plants, but I'm going to switch that over to the 3-dimensional nodes. So you can see a little bit of something fun going on that might be kind of hard to see actually when I have the generalist plant plugged in. Oh, it's still kind of noticeable. So back here in this environmental analysis section, I passed up this one particular block of environmental analysis here. And what this is doing is we're using what's called an add feature proximity layer. So we're saying we want to name this proximity the edge proximity, and we want the feature that represents the edge proximity to be the planting zones. So it's taking the edge of these planting zones and it's using those as a proximity reference. And then what we're doing is we're using now the rule restriction gradient to say, let's use the height of the plants. So the attribute is the height of the plant. And we're going to arrange the plants now so that from the edge of the planting area towards the middle of the planting area, the plants get taller. And it's a little bit harder to see when you have a lot more analysis layers layered into it, especially if you don't have a wide range of plants. But you can see that these like red plants are a little bit smaller, and then you move into the white plants, which are a little bit taller, and the yellows, and then these blue ones are actually taller than the white and the yellow as well. But it's kind of a fun way. You can use this for a lot of different things. You can actually use these gradients to, let's say, if you want to make sure that you have plants that are salt tolerant along the edge of sidewalks and roads, you could actually use this proximity layer here, the feature proximity, to find the edges of your sidewalks, and then use the rule restriction gradient to analyze the pH value or pH preferences of a plant, and make sure that only plants that have certain pH values are placed closer to sidewalks. And so that will allow you to deal with plants that are, having to run into high pH or low pH based on salting of roadways in the spring or from winter to spring.
I think there's actually even a salt tolerance column in the ERA. I could be wrong, but I think it's actually specific.
I think you're right. I think you're right. Yeah, we don't have it in here.
Okay.
I don't think so. But there is a salt. I think you're right. I think there's a salt tolerance column that's based on sort of the ERA's determination of what qualifies as salt tolerant versus not salt tolerant. So that's kind of a fun rule that allows you to add a lot more into it. You could actually probably augment this to work for the fragrance as well, so that the plants that are closer to a trash can are more fragrant, because you don't have to use a curve here. This could actually be just a breath that's going into this, and use the breath, the trash can, or something else like doorways. You could actually do a restriction gradient so that the closer you are to a building's doorway is more fragrant plants or something of that sort. So these are kind of fun tools to add to the design a little bit. What else do we have in here that you haven't seen? I think it's a couple of the outputs down here. So we'll go into those and showcase that. Like we were talking about in section module 2, we would show you guys the sort of little fancy scripting that we added to this one that allows you to take those blocks that you've used on the site, the 2-dimensional blocks, and place them on the site that are referenced also to now the plant schedule. So you can see that the symbol is associated with the appropriate symbol that's actually being placed on the site. And like before, you get all of your niche and number of plants information down here. You can see that the general list has quite a few different plants that are being used down here as well. So that's kind of fun. That's what this block of script is doing right in here. And this can be sort of modified or changed around, I get, which Chris and Justin were talking about just before we got off the break as well. The other kind of cool thing that you'll see over here is we have a generated bloom calendar. We have a component that will generate you a bloom calendar. And we have 2 general graph types for this. I think it's defaulted at a radial one, but you can actually switch it to a bar version of it, just like a more general graph version. Shouldn't change this in a while, but you can see it's realign those, and when you zoom in, it will apply the color to it. It will apply the bloom range that it's reaching. It will apply the name just above it to tell you which species it is. Yes, go ahead, Chris.
Yeah. So also, if you go back over to where you see the plants and plan, keep the grasshopper where it is. Zoom in on this, and then you can, if you plug this animated, this is the animated version of the plants. So, oh yeah, is that the one we're using?
Yeah.
And right now we're at month 6. So that's, I don't know when that is. That's like June, right? So you can actually move through that timeline, and it will show you the bloom over the course of the year.
At 7, it will change it so that now we're seeing the plants that are blooming in July. And you can switch it to August. You see that plants are just starting to peter off. It's kind of fun. Or you can just go straight down to November and see that probably the only plants that are going to show up are the generalist plants, which don't have a bloom value to them or a flower color to them. So that's kind of fun. Yeah, and put this back up here, put this back in. Yeah, and I think that covers. There's not like a whole lot more here left in module 3, Chris, and we still have about an hour, which will be fun because you can. I think that gives a lot of time to explore the more unique and interesting things about Plant Kit that we've been exploring too. That are like kind of exciting. Diagrams made easy for sure.
Yeah, and it gives me time to kind of like do my sort of demo like in a more full way. So yeah. This is cool. This
is good. And again, if you have questions, I'm gonna hand over the sharing to Chris, and I'll still be available in the chat.
All right. So this is this is module 3 or module 4, and I just don't worry about going into module 4 yet. I want to kind of show you what's happening here first. But basically, we have our a bunch of plants here filling in. I've removed the color constraints on this. And so, but you also might notice a greater variety of plants. And what I've done is import the actual CSV from the ERA. And then we're filtering the actual the plants that it's grabbing by using this query. So the query lets you input multiple values to say whether you want something or not. It's pretty nice. So it has to meet these conditions. So in this case, the US distribution has to include PA, like it has to be in PA. It's false that it's going to be, the pollinator value is going to be very, very high. So if I just double click on that and say true, it's going to change the plants that I have. And now I have this different set of plants. But I'm just gonna go back to the wider variety here just for now, just to get more range of stuff. And then you can also say plant types that, let's say, it looks like I messed something up. The plants that we don't want should be trees and vines should be false. I don't know how that happened, but so we don't want trees and vines. And this will probably actually give us a much higher quantity of plants here. So and it looks like it's strange because it's like remembering something strange here. Sorry. See these colors? That's what I'm going to show you. Okay, that's much better. Okay, there we go. So I'm going to just actually lock this. I think what's happening is it's reprocessing some. I'll explain what it's doing. It's actually something I need to fix. But so you can turn certain stuff on or off here. And it gives you a wide range because we're pulling from that whole database, and this gives us 1,200 plants. I mean, it's crazy. So what we might do is say, okay, really just take it easy. We only need 50 plants. Just to start generating ideas that maybe we want to create a hyper native garden, and we just want to start to think about like what plants could go together and stuff. And this starts to help us like kind of see those. And it looks like it keeps applying this pattern for some reason. So I should just show you what this is at this point. But one way to refresh things that are random or things that like maybe are referencing Rhino in some cases is just to like replug it in, by the way, just so if I just want this component to refresh, this is one way to do that. So this is giving me a whole different set of plants, a different plant list, but we're ending up with this with similar colors. And let me show you why that's occurring. So we have an analysis layer called an analysis component called add image layer. So the neat thing here is that I can in Photoshop. So what I started out doing is I captured the size of the site. Like I just did a screen cap of like the section 3 here. And so you've got like section 3. And then I started sketching over where I wanted different colors, so I can sample a color, and then I can kind of say, all right, I want purple in here. That would be nice. And then maybe even a little bit of purple in here. And then I can say, okay, that's great. And then turn this layer back on, hit save. And the reason I have to do this second step of saving as a JPEG is because I like to have the multiple layers. So I'm just going to do, am I doing it wrong? There we go. Photoshop has this new wonderful way. You can't just say save as JPEG. You have to use this weird thing. I don't know if everyone's noticed that, but it's super annoying. And then you say save. And now it's going to update this. I go over here and I can just plug this in again. So I have this image I just dropped it in as a picture in my file. So look, you can see it updated automatically in Rhino. But I just need to refresh it here in Grasshopper. I guess I could also bring it in via a geo pipeline. Oops, my Zoom died. Let me reshare. Sometimes it just relaunches, but it did not do that this time. Oh, geez. I'm talking right now. Hold on, sorry guys. All right. Sorry, I canceled because I thought it was telling me something else, and it was about recording the meeting, and yeah, fun. So share there. So yeah, so you can plug in. I've just plugged in again, and if I simply change the list of plants coming in here again. It's thinking a little harder because it has more plants, but you can see that it's updating the planting design based on these colors. The really fun thing here is that we are still doing sunshade analysis. We are still doing soil moisture. We are still doing fragrance and everything else, and we're applying all of those things. And actually, we're still doing the flower color, but our analysis layer for flower color is now generated by this image, right? This image component. So we just use the same name, so it's interoperable. And I can adjust that stuff that easily. Just trying to. I know I kind of jumped in through this like how to bring in the ERA stuff pretty quickly, but I think Ben has established a pretty strong foundation now for like how the data gets brought in and stuff, and it's now we're just dealing with a lot more plants, and we have to decide, like, we have to just make a little bit more decisions about which plants we're using and how to filter them and things like that. So if I just plug this in one more time, you'll see that it'll be a lot of the same appearance of color and stuff, but it's going to be a slightly different plant palette. The neat thing here is that because we're using the cushion for the color, we get a variety of purples, right? So the cushion allows for a range of purple, or a range of green, light green / yellow. It actually even encompasses yellow in the light green. And it's a way, we thought this was really important to show you guys, and well, also to include the fact that you can delimit color based on a very painterly approach, or based on an approach where you want to draw shapes, because this isn't, I think a lot of people hear about PlantKit and think like it's like the super wonky thing. It does have some technical aspects, as we've learned today, but I think people think that it's this thing that it's the computer is figuring everything out for you, and is sort of giving you a design. But you're determining all of these factors and all of these rules, and which which environmental layers are important and what are the relationships between things. One thing we didn't mention is that you can actually literally create a plant niche for a plant by using another plant's name, and then the domain is the distance that that plant has to be from that other plant. So you can actually do sort of build plant communities that way as well. That's probably something we could have included or maybe tried to demo. But there's a lot of things that you determine as the designer, but the thing you're not doing is drawing circles. Like you're not like literally placing plants and having to remember all of those things that are happening with sun, shade, soil moisture, where I want different colors, where I want, like however many dimensions that you've brought into the problem, your problem space, you're not having to memorize all of that stuff in order to place a plant. And then not to mention the whole iteration aspect of it, right? So do we have any like big questions kind of coming out of this? I know we're like, wow, we're like really ahead of schedule. And we could probably go over some things more in depth. Is there any areas that like were fuzzy for people that maybe you want us to kind of illuminate or dive into, or is there things people want to try?
Well, I think this is super exciting, and that it's been fun to just play with the image tool. One of the things that I was curious about on the last module was animating the different bloom times. It's just a really useful thing, and having a similar animation for like evergreen and deciduous, having that feed into it. So that would just mean, pulling a different,
Yeah,
rather than the
thinking about different data there. Yeah. So what it will do is if there's a column called fall conspicuous, it will show that there it will show that there are, there's like some kind of color at that time of year, or at, I basically we've phoned it in a little bit, and we basically just made it for the northern hemisphere, like for the fall, like the general fall months. But I think, yeah, it would be interesting to sort of think about, multiple colors over the course of the year, because like a lot of plants go through really a wide transformation of color, and we haven't figured that out yet. And part of it is that data doesn't exist, right? Part of it is that we eventually want to build on all of this, and we think it could be great to actually start to do that. So
with this job bloom calendar, could you copy this and then just change the fields that it's looking to? So if you wanted to do just like a show the evergreen plants in a similar visual style as what we're doing with the showing plants that are blooming in June, could you change the field that it's looking for and use the same component?
Yeah, hypothetically, I mean, you could sort them into two lists and then just treat them completely differently. That would be like the most immediate way. So like you could have all the plants going in and say, if the data value is evergreen, then do a dispatch, like in Grasshopper, you can just create a pattern of true or false, and then it will put everything in true in the A column and everything in false in the B column. And so you could like take out all of the evergreens and then just color them a certain kind of greenish color, and then you could put all of the bloom plants within that bloom calendar, so you could like visualize the bloom, but it's showing that the green stays and is more permanent. The other way to do it is to literally make the color of the conifer like green in the spreadsheet, and then make it bloom all year.
Mm-hmm.
Right. But that's
like
kind of,
there is a column though already for, well, in leaf retention evergreen. So you could filter by that, right?
sure. Yeah, you could also do that. Yeah. Yeah, there are a number of ways to get much more in depth with this. For sure. Yeah, we should definitely keep pushing on that particular aspect of it. We've seen this as kind of like a bonus round, you know, like a thing that, you know, it's like on top of being able to kind of place all these things where they need to go and whatever, you can then visualize like what's the bloom throughout the year generally. And but yes, there's a lot more effects that happen other than bloom, like when it comes to color. Like you've got the fall color, and you have the changing of you know, even conifers over the year, and like how do you kind of coordinate those colors?
Capture, yeah.
Yeah, so there's probably usually when I get stumped, I like an hour later I have a pretty good solution for it. But I think, you know, maybe there's a database of, you know, it's like plant, just like a separate database just for that particular project, and you have like the months of the year as columns, and you have like a color for each, you know, just color values for each one, and then you effectively like use that to read the name of the plant, and then you can kind of visualize the color that way over the course of the year. Might be the cleanest way, so that you're not trying to kind of like bring all of that information into a much bigger database with a lot of other data. But I do see the appeal of having all the data in one place, obviously, but that data is also going to change based on what region it's in. So that's like, so it gets even more complicated. Yeah.
Yeah. I mean, it's really cool. I just seeing the evolution of the tools and the how much more you've built out in terms of how you visualize the like,
Well,
Yeah.
I'm curious. It sounds like Laura, you've seen it in the early stage. Like what changed, or my big question is like, how have you used it, or when? Like I think the power of it is what Ben started off saying. Like the traditional way of designing is like, I'm going to have X number of zones. These are the plants that are going to go here. And I learned land effects, which I think is a super, I don't know if Laura, you've used it, or Chris, Ben, but it's just like you assign a hatch and it's calculating the hatch. You plug in the spacing, and it bangs out a table for you with all the information.
Mhm.
So what I like about this is that it's just like pulling from a random list, and while you know you want to have some control over that, I think it's like informed based on the constraints, and maybe you don't start off with the list at all. I think that's really interesting.
It's
Like
like I said, I'll
a
say it again.
set
It's like,
number of plants.
yeah,
You know,
we see it
I
as an
think that's really
exploration.
interesting. Yeah.
Yeah, an exploration tool. And
Actually,
also a computational design tool. Like, right. So it's in some ways it's about, oh, how can I do planting more efficiently? But that's part of it. Like we do know that there are some other software that sort of, you know, increase efficiency. Like there's stuff in Land Effects, and there's stuff in Vectorworks and Lands Design and all that stuff. But this is like the only example of like rules driven planting design, you know,
Yeah.
where you can set up multiple layers of rules, and you can do all these different sort of operations to your planting, and change the pattern based on packing, and not to mention all the crazy fun stuff you can do with Grasshopper, kind of like as inputs, or like kind of after effects of all of this, right? So that, and our hope is to get landscape architects using tools like Grasshopper, specifically Grasshopper. But we are recognizing, though, that there's a lot of technical hurdles in order to do anything near like this from scratch, right? So we're trying to build these tools that help to make that much easier and make those stepping stones easier. This was definitely the deep dive, and we got really into a lot of different things that you can do. But the cool thing is you have all these templates now, and you can kind of, like take that template, make it part of your office template, or you can make it your own, unique template and sort of, blow the barn doors off of your colleagues. But I think the other thing is some folks have come to us sort of wanting, like Laura, wanting to kind of not just help themselves, but help their whole firm or their students or something. And there's a lot of learning resources, materials that we've tried to provide, like example scripts for these other kits as well. And the neat thing is that when you plug this in, all the topography stuff we've seen here has been static, but imagine having all of the topography stuff also be dynamic and be able to change something with the topography and then have the planting also change. We've done a few small sites where we've had everything plugged in at once, where it was, very small sites this will work on. But the larger the site, the more you've got to break it into different, how do you eat an elephant? You have to, just take the first bite or whatever. So you've got to, I don't know, is that a thing?
It is now.
So it is now. It's pretty gross. Who'd want to do that? But yeah, so I think, for the bigger projects, you start to sort of say, okay, well, we're definitely going to have a planting script for things, or you might even have 2 planting scripts. You might say, okay, for this particular typology of planting, we're going to have one planting script that just deals with all of that, and then for this, or maybe this area of the design, and you have a script that does that, and then you do like a new version of that for this other area, and one's more about grasses and wetland or something, and then the other one's more about like a floriferous garden or something.
A couple things that were said spurred some thoughts to particularly what you said, Ishan, about you could even start with no plant list if you want to, which brings up the idea of the pseudo plants, which may be worth showing them as well, Chris.
Yeah, I can do it
up in here. And then
I can do a quick demo of that.
The other component that might be fun to show that we haven't used a lot, but was developed sort of out of some of the parameters that are included in the ERA, is the set age component, which I don't know if that works as efficiently as it's supposed to now or not, but
yeah, that's right. So there's a component called set age, and Ben, I don't know, can you show me the data, or does the database have growth rate?
let me check. You have the ERA plugged in, right?
Yeah. Oh, the ERA will have it. That's right.
Yeah, the ERA should have it. I know it was, you put that component in there because of the ERA database.
That's right. So if I plug in all of these plants, looks like we're getting some errors. I'm not sure what's going on, but we might need to skip that. I'm not sure why.
We haven't debugged it in a long time.
We haven't debugged it, and actually, I think we've used it a lot with that other database, the Village Circle database. So we may need to look at this, but so this component hypothetically is supposed to let you change the size of it. Changes the size of the plants based on the year, and it decides what the size is as a function of the year. And it says, at a mature height between 0.5 and 100 feet, it will go, if it's slow, it will go from 5 to 200 years. And if it's moderate, it'll go from 2 to 50 years, and rapid 10 to 20. So it'll map each of those ranges based on the speed of the plant. And then and then based on, like I said, like a size range. So from 0.5 to 100. So if it's 100-foot tall species, a slow growth time is going to be more like 200 years or something. Or if it, it's maybe that's too long, but moderate is like 2 to 50 or something, and rapid is 1 to 20. But if it's like a 1 foot tall plant, the slow, moderate, rapid are going to mean something very different. So, and that's just kind of a generalized way of being able to sort of visualize the size of your plants on your site over the course of multiple years. So not only can you do the bloom over the course of the year, you can also look at size over the course of multiple years. And we'll have to look at that and get that working again very soon. I'm not sure what happened there. I think we've been using it so much with this other example that, or we're doing something funky here. Oh, you know what I did? You know what it is, Ben?
The generalist plant.
I think it's the generalists. They're messing us up.
It doesn't have the.
What I need in there is something that skips over plants that, no, that didn't do it. Because I didn't add anything to it.
So just feed the first planting one into it.
Yeah. Well, I can just try this one here. There you go. There it works. So we can try to plug that into, where are we visualizing it?
The bottom one.
Is it the bottom? Oh, right.
Not the bloom count or the bloom count.
Right. So this is year 1. Oh, God. Okay. So it's not broken. It's only like broken in one little case. If you add plants that don't have, so that's year 1, year 2, you can see the rapid growing plants there. Year 3, some of the other ones are filling in a little bit. Year 4, a few more are still filling in. They must be slow growers. And then year 5 is all these small plants are pretty mature by then. So it's still it's an art, not a science in this case, but it's at least a way for you to start to kind of make sense of scale and stuff. The other thing that we've done is we've used set age to actually use as a design tool to say, okay, how big are plants going to be? And we've looked at saying, okay, if plants are going to be big early on, then the plants we plant under them should just be really short-lived plants. And we've actually created like subzones and a unique analysis layers and things like that. And this can get very complex. You can really set up more complex relationships because it's simplifying a lot of the complexity of like just the standard, filling based on constraints. But yeah, let me do some pseudo plant stuff. So if we go up here to plant kit, there are these 2 symbols. There's the pseudo plant parameters, and then there's pseudo niche parameters. And so for the pseudo plant parameters, you're going to want to input I have this cluster component that just has a list of colors. So I'll just plug that into here. And then it has a basic minimum and maximum number of species. 5 to 10 species. And then you can use a button to activate that. And I like to invert it so that it's like, it's active now because the button is now true because I've inverted it. But if I click on it, it like refreshes it, right? So it's like a quick refresh. And the pseudo species are a way of generating even more abstract plants, right? So plants that aren't even associated with the species or anything. Like it's like, how can I try a bunch of, plants sort of in a conceptual way and kind of find plants that have different parameters, and then maybe I fill in which plants go into those, meet those criteria later. Like I get an abstract list of like sort of prototypical plants that would fit, or what are they called? What were we calling them on the Village Circle project? It was like not archetype species. I don't know. It was something like that.
Yeah.
But anyway, so you can plug in, you actually get a random number of, a random weighting. So each plant has different weighting to it. And then you can say, you can put in for the niche parameters, you can input the environment. And what that does is it gives you a bunch of constraints based on what is it? Sorry, based on what are the layers that are actually in the environment. So if I show, it's probably better just to show you. So it's going to be using sun exposure, fragrance, soil, moisture. And then the domains for those things are all set based on different available conditions within the site. So it's generating random stuff, random conditions that the environment wants to see, you know, here. So then and then the cushions, I think, are all 0, but you could sort of input some, you could like randomize cushions or something parametrically or something like that if you wanted. But the fact that it's random already sort of doesn't make sense to have cushions so much. So then you create niches. So just the vanilla kind of create a niche, and you just plug those into there, those into there, those into there. And you get a number of niches, and then you can just flatten those. And then we do create plant. And then so here you plug in the radius, color, the height, that you can do cell spacing, you get that niche in there, and the cluster radius if you want that. So now we have a whole new list of plants. So we just say save, and we plug this into here. And let's see what happens. See if it blows up. It probably is going to freak out based on the bloom calendar. We may want to skip that because there's no real there's no bloom information in these. So it looks like it's filling very few. You can also put the weights in here.
How many different plants are you generating?
I'm only generating, like right now it has like 5 or so plants.
That's probably why. Because we have so many different layers and it's creating random values for each of the different types of constraints.
Yeah.
A lot of overlap with the different site conditions.
I wonder if it's also, usually we don't just like willy-nilly plug in our pseudo plants in. I'm wondering what's going on here. Strange. What am I missing? Cluster radius. It might be this. Wonderful. One last thing we're going to try here is if we look at the different, if we look at the constraints coming out of here, you know, we're constraining a lot of stuff. We're saying, okay, you've got to meet 5 different constraints in order for a plant to be placed, and we only have 8 species. So like the likelihood that things are going to match is maybe very low. So what we can do is we can I'm just going to copy this data here, and then oops, and then paste it in. And then I can just use, oh, it's giving me everything, but I can, just use those parameters. Sorry, this is a little unrehearsed. I can just use those parameters as the parameters. So it's just sun exposure and fragrance. And I wonder if it's because we're using something like fragrance that, no, there we go. So that gives us some, more, a greater variety. And I think we were just over constraining our plants, right? So we were 5 different layers of constraints is pretty intense, especially when it's just randomly located across the site. A lot of our plants are actually fairly forgiving, because it will say sun, comma, part shade, and it can actually exist in a wide range of that environment. And maybe we should change some of that for our pseudo plants, but let's say we give it a larger number of plants. And then I just locked it real quick so that I could plug a couple things in without it slowing down. So yeah, now I have a wider range of plants. And you can also do fun things here, like just multiply the radius by 0.5 just to get a better, a better sort of understanding of maybe some smaller plants, and to see that. And maybe we plug this cluster radius back in to see some clustering. The clustering can actually be pretty neat in the pseudo plants. You can add clustering into your plants as well, and your so we could make this just double the clustering value that the pseudo values are putting out, and then you'll see larger chunks a little bit. I think there's enough species here. 20 species is kind of intense. Maybe 10 would help. But yeah, you can kind of see more clusters of things happening there, and how quickly it'll show, real patterns emerge. Like, okay, that is seriously its own zone. And you could even document it that way, right? You don't have to sort of, in this case, you could like maybe actually rationalize this when you're going to document it for a contractor. Trying to think of other things. So one other thing we mentioned was this idea that you can place individual plants. So if I were to sort of, place some individual plants. So I'm gonna take and draw a curve. And I don't know which layer. Oh, that's an okay layer. I set one curve, and then I divide. Oh, actually, there's a row thing, which is pretty cool. So you give it a curve, and then the spacing, let's say 0.1, which is, and then you can give it a plant list. It's getting a little hairy here. You can give it a plant list, and did I leave? I left something over here. And then, well, the neat thing is here, you could get the plant info and do a preview and just visualize these. So the sphere and the color. And we've got a row. It gives us a row of plants that are all based on the list that we had, right? So it's a row, a list of plants. We can also then say, fill these into an area and use these areas. And I'm doing a bit of splicing here. Could hide these real quick. So before this goes in, we can add plants there. So now we have plants, and if we were to do packing, there are different ways of dealing with this, like the overlap here, but if we were to do packing, because these are fixed, are these fixed? No. Because these plants are fixed, they're not going to go anywhere. They're going to, I think, no, those are the ones that are false. True. We'll make those fixed. So then the other plants should sort of hypothetically shift around them. It's pretty tight, so it's probably why we're not seeing a very clear thing. But if we could have, you know, multiple rows, and the neat thing is that the row doesn't have to, like, it'll automatically call plants that aren't inside of the area. It will only ever place plants inside of the area. So I could set multiple curves. The one thing here I have to pay attention to, yeah, this actually grafted, so I want to make sure that it flattens it, because otherwise I end up with, oh no, it looks like it does flatten it. Yeah, but the other thing to do would just be to say, okay, Phil, just skip over this, and you can see that it, like, will do the thing that Justin was asking about before, which is a bunch of rows of plants. You could do fewer of them. You can also, like, if you think you know where plants should go, like you have a bunch of locations and you have kind of a list like this, and you think that they could go there, you can also turn on, this is actually set to, oh no, it is constrained. So these are actually constrained when they go in. So you can also make this true or false again here. So like you could say, okay, well, these are, I don't care, these are going to go in. I'm, you know, this is what I want to fill in here. But yeah, does that make sense? Like the explicit fill that you can do.
Yeah. I'm not sure I understand the spacing. I think you said you use the paving kit to create the pattern. Because
Yes.
how would you then, like, okay, you get this beautiful drawing, but is it space to the plant?
So
Like certain zones, like a wetland will have X spacing, a meadow will have X spacing, this shrub area will, like, how do you control that? Would you
okay,
take the
so
shape and divide it and assign those points to the?
so the way paving kit works, this is a little paving kit demo. You have geometry going in, just shapes, right? Just like we have for the planting.
Yeah.
So you're just using the
Right.
same exact shapes for the paving kit. And then you're literally, we're just using all the defaults here. We're doing a pattern that's, the default is like a herringbone pattern. So it's like, but you could do a grid. So if we did a 0 for the pattern, it's going to change the layout here, and we'll end up with like a grid. But I think that because the length and the width are a little different, it's going to be spaced a little funny. But if we had both of these at 2 feet,
Yeah, it's
right? The default is 2 and 1. This is going to, you know, make a grid. But what you could do is you could have a different set of spacing for each input. So that like right now I have 5 different inputs. So I could create a series. This is just an example, just random. And I say list length, just based on the length. So there's, you know, the spacing can be, I should start with 1. Starting point is 1. So the spacing can be 1, 2, 3, 4, or 5. And if you just put this into, I'm just again going to lock it briefly before and then I unlock. It's gonna, for one of these, it's gonna be, you know, 1, 2, 3, 4, 5, or something like that.
Oh, nice.
Right. So you could have different values for different areas. Another way to do it would be something I've done in the past.
Yeah.
I'll go ahead.
No, to have separate chunks of this portion for assigning it to different curves.
Exactly. So you could do it based on layer names or something, but
Yeah,
I like to use the object name. So if you just say, okay, the object, you know, the spacing here is 2, and this is going to reprocess, but the spacing there is 2, and then the spacing here,
oh, super smart,
is you know, 3, and then what you can do is when they come in,
the series.
yeah, you
You
can
have to tell
override
it
that.
to read it though, right? Oh, it
Yeah,
does it
so
automatically.
No, you say it's still reading that series. So you say details, object details, you plug this in and you get the object name here. And you just plug that into
this
block again to there. And then you say, ta-da.
Yeah.
And so you can define which things, you know, which kind of parameters go where. So these are now 2, 2, and 2, and then it's 3 and 3. I liked it when there were more species. Isn't this fun?
It is really fun. I feel like until I actually do it, I'm not going to get it. But it's super great to see.
Yeah, it's going to take a little bit probably. We can you know, pitch all these at 45 degrees. Or you could, like Justin was asking about, you know, you could always do the rotation as a function of the name of the you know, the area curve, right? So you could say, okay, well, this one's going to be at 45 because or you know, at 30 degrees because I want it to go here, or
okay,
you know, and each one, so you can change different parameters. The only thing is you run into a limit where it's like, how many different things can I assign? But since we're here, I'm going to tell you there's a way. So let me just create a new Grasshopper file real quick so that we can do this. But basically, so you have the name, but let's assign a whole other set of data to this. So if I select all of these, and then I say under properties, you can go here. This is attribute user text. It's like data you can store in Rhino objects. So we can create a new value that's angle, and then we can apply an angle like a 45, right? Say okay. And so I want these to be 45, but I want these to be 90. So I select both of these, and then I change these to 90. Oops. And then similar to before where we were grabbing the details of the object, this is a native component, but a lot of what we like to use is Elefront. Elefront like lets you bake things and stuff really, really well. We can get user text. Well, let me see. I'm trying to remember how to do it actually. So you can get user attributes. Yeah, I think that's right. Or get user value. Actually, this is even better. So you plug these into here. You create a panel that's angle. Plug that in, and now you've got all those values for angle or rotation. Plug that in, and we'll get a variety of angles for the different zones depending on what you've defined. So that's fun. It's also something we've never done. So we're kind of like, sort of responding to your ideas here, and that's what makes this a workshop, even though there's only a few of us here, which is still fun.
Triangles is, so the pattern could also, like, how would you do triangle spacing? It's just
you just change this to 3.
change a number, yeah, instead of 2. Yeah, okay.
Yeah.
So you're shifting it 1.
Yeah. Actually the best one for plants like this, I think, is actually, and it looks like we're doing some packing here, which we don't want to be doing. And it's also slowing us down. We're only noticing it because they're getting dense enough now. But the one that works really well is a hex. So a hex pattern. So because what it does is it does that kind of, it does the tri grid,
Yeah.
And it's a little hard to see because it's at a 45-degree angle, but it's essentially, it's rows that are offset, right? Yeah, so that is fun. There's a lot of stuff we can do with Paving Kit to create pattern, and so that's a whole other realm of exploration. You can do these standard patterns, so there's like a grid, a running bond, a hex pattern, tri-grid, herringbone, radial, and then there's also some of the pro components allow you to do modules. So you could have like a large grid and then plug in
that on the website.
Plug in other ones, or create your own tessellation. Like, and what's neat about this is it lets you kind of design your own tessellation as well. So you can kind of like, you set the different offset points, and then you draw any geometry you want for that repeat pattern, and then it kind of shows you how it's going to repeat in a short form, and you can kind of like adjust it until it's right, and then you can plug it into an area and make it really, you could start with a small area and then you could kind of go big, and you can still rotate it and it'll trim it and all of that fun stuff. But yeah, a lot of that stuff doesn't make sense here, where we're just designing, whatever. But another interesting way to think about this is if you were to plug these in and make surfaces out of them and then populate them, like populate the geometry. So this is just like 100 points per area. And then they're just random. You just plug those in and now you have, so it could be very arbitrary. You could have all kinds of different patterns set up. The other thing about buffer that I forgot about is that you can, so if I plug this guy into here, and did I ever set up? I might not have set up buffer for pattern. Let me see if I did. Hold on. I think my little guy's awake. Might have to go.
It's fine.
Yeah, the buffer works. I know it works with the non-pattern version. Yeah, this is something I still need to incorporate. But in the non-pattern version, like where it's just organic, it will only place stuff that's a certain distance away from stuff that's already there. That's actually what buffer is. I don't know why I had a memory glitch there, but yeah, Ben, I may bow out now and let you kind of field any more questions. I'm really glad you guys hung around. I know it's Friday afternoon. It's probably time to go like get a beer or something, but we're excited to kind of hear how you're using this. I know, Justin, I know that Cirrus, does he like Cirrus or Cyrus? I forget.
Cyrus.
Cyrus.
Ben knows. Okay.
I don't know who Cirrus is.
Who's that Cirrus?
I don't know who that guy is.
Who's that guy? Yeah, so I think, yeah, I know you guys are both going to be using it, so hopefully you guys can feed off one another, but you know, if you have questions, we would love to work with folks who are, you know, you too, Ishan, obviously, but we'd love to work with folks who are using this and in practice and help you get through some of your hurdles and things like that. We're even available for consulting to actually set scripts up. If you're like, okay, I get PlantKit, I get what I want to do, and I know I can use it, but I just don't know how to get it all set up. We could, like, as a service, like, we can help set something up for a particular project, or set up some kind of unique parametric relationship that maybe doesn't exist in the toolkit for your particular project, and then let you kind of continue forward with it. So it hopefully provides a lot of paths toward success, you know, planting success, which is our ultimate goal. You know, there are sort of one of our best weapons with climate change in some ways, like kind of like, it's like more plants, please, more ecological, ecologically accurate,
Savvy. Yeah.
and savvy planting designs. Exactly. And this allows you to set up all those rules to do that.